Hello, my name is Juna Park, and this is my presentation for CSE 335 final project GeoNote. GeoNote is an iOS application designed to enhance note-taking by integrating location-based reminders, weather information, and flashcard studying features. Today, I will walk you through the app's core idea, features, technical architecture, limitation, and what I learned during development. The core idea behind GeoNote was to create a more context-aware note-taking experience. Many of us take notes tied to specific places, things to buy at the supermarket, research topic at the library, or study materials relevant to locations. GeoNote addressed this offering by standard note management, creating, reading, updating, and deleting notes, CRUD, and location-based reminders. User can tag notes with a specific location, latitude, longitude, and radius. The app uses core locations geofencing to trigger a notification when the user enters that defined region. We use the location manager and CL circular region. Location context. Notes can be tagged with a human-readable location name. Integrated weather. For location tag notes, the app fetches and displays current weather conditions using the Open Weather Map API. And flashcard studying. User can create sets or a flashcard with front-back content, enabling studying on the go. User authentication. Secure login and registrations are handled using Firebase authentications. The GeoNote is built using the MVVM architecture, extended with a service layer for better separation of concerns and testability. Model. Represent the app's data structure like notes, user, flashcard. These are the simple structs, often codable for data persistence and identifiable for Swift UI. View. Built entirely with Swift UI. Views like Notelist View or Login View are responsible for displaying the UI and capturing the user inputs. They observe view model for state changes. We use state object when a view owns its view model. We use observed object when a view model is passed into a view. An environment object for view model shared across multiple views, like node view model used in home view and node list view. View model. These are the observed object classes. They hold the state for the view using published variables. When these variables changes, the observing view automatically updates. View models contain the presentation logic and interacts with services to fetch or save data. For example, when the save button is tapped in create node view, it calls view model.addNode method. The view model then uses node service. Combine is used extensively within view models and service for handling asynchronous operations like network request or database call, returning result via any publisher. These architectures makes a code modular, easier to test, and maintainable. This is the use case diagram for GeoNote, which captures the main interaction between the users and the system. At the center, we have the user, who can perform two major groups of action: managing notes and managing flashcard sets. Under managing notes, user can create, edit, and delete notes. When creating or editing notes, they can also tag it with a specific location. The location can trigger a location-based alert, which uses core locations geofencing. The note is then saved to the backend using the store data function, which interacts with Firebase Firestore. Tagging a location involves external data from location search. Additionally, if a geofence is triggered, app use automatically open the relevant node using the GeoNote node's location metadata. On the flashcard side, the user can create, edit, and delete flashcard sets. Each set includes individual flashcards that can be created and edited separately. Each flashcard can have a front and back, question and answer, and both sides can be updated. These actions are included within larger edit flashcard process. All data related to flashcard is also persisted using the same store data function via Firebase. Overall, this diagram illustrates how different features like notes, location alert, weather, flashcards, and backend data are connected under unified user experience. While GeoNote implement was many features, there are some limitations in current version. Offline support primarily relies on network connectivity for Firebase data and weather fetching. Geofence reliability. Background geofencing can sometimes be delayed by iOS depending on system conditions. Limited search filtering. Node search capabilities are basics. This project was great learning experience. Key lessons learned include Swift UI state management and asynchronous programming with Combine. integrating core location and value of MVVM plus service, Firebase integration. Finally, I would like to offer some feedback regarding the class and project structure. Overall, the course was highly informative and practical. However, I believe it would be even more helpful if there are more examples provided, especially for deliveries like MVVM diagram, class diagram, and user flow diagrams, since these types of diagrams were required for almost every major assignment. Having a few detailed examples would have made it easier to understand the expectations and create more accurate submissions. Additionally, it might be beneficial to incorporate more real-world project walkthrough or short case studies during lecture. Seeing how large apps structure or their code base or solve architecture challenges would help bridge the gap between academic exercise and industry practices. In conclusion, developing GeoNode was challenging yet rewarding experience. It showed how powerful Swift UI and BBM architecture and various iOS frameworks can be when combined thoughtfully with backend service like Firebase. Thank you.